Hello everyone, my name is Timothy Lee Grant. Today we are going to reattempt to try to solve and conquer this problem. Number 33, search in a rotated sorted array. I tried it yesterday and failed, okay? I passed the 3 test cases, but then I failed on the other test cases during the submission. So obviously I didn't get the right answer. Today I am going to try it again one more time and just I looked at the answer last night. We'll see if I'll be able to solve it today. So let's try that. Minimize myself. And so this problem, the idea behind it is we have an array, okay? And this array is in sorted order. So it goes from lowest to highest. 0, 1, 5, 8, 12, 35, right? Then this array is shifted over by some amount, and the amount that's shifted over gets placed in the beginning. So you have two continuous increasing sections with one point in the middle which is non-continuous, right? Like it's a break. Now the question is, I want to find a specific target in this array. So I have my nums. Okay, so nums is going to be my array, and it's equal to whatever. Let's just say let's see, 1, 2, 3, 4, 5, 6, 7. I'm going to go like that, and then let's see. So then I shift it over, right? So I do this, and then I put it there. Okay, so that's shifted over. Okay, and now let's say I want to find 4. Okay, so that's kind of the question is, how do I find 4? Okay, so this is binary search because we need to do it in log of n time, or O of log n time. So we're going to be doing the binary search thing. So we're going to be trying to find the middle. And then the question is, and this is what I always need to remember in binary search, is thinking about which section I can throw away each time. Okay, so I'm going to try to do this. So we have left is equal to 0, because that's going to be our left pointer here at 0. We're going to have right is going to be equal to length of nums. But length of nums gives the number of elements. So this one's going to be 1, 2, 3, 4, 5, 6, 7. There's 7 elements in here. I don't want the number of elements. I want the number of, or the index, this last index. Okay. So now what I want to do is the standard while left is less than or equal to right. I want to find the mid, and mid is going to be equal to left plus right integer division 2. Okay, so that's normal. Now, just as normal as well, so if nums of mid is equal to target, we can return that index, which is m. Okay, so that's normal. Now comes the difficult part of trying to think about how to arraign, or how to throw away part of our section, right? So let's say that I find this 1 here. Okay, I find the middle and it's 1. Okay, and I'm looking for 4. That's my target. So 1 is too small. But notice in this section there's too small, or it gets bigger. And in this section it also gets bigger. Okay? So I can't inherently just throw away part of it. Normally in a binary search, what I would do is I would just say, okay, well, my midpoint is too small. I'm going to move my left pointer over here and get rid of all the values I know that are already too small. I can't do that in this case. The key concept here is, okay, well, now I can look at my bounds, and I know that this bound is going to be the biggest number in this section, right? Wait, no. Sorry. No, I actually don't know that. I need to determine where the pivot is. Okay, so let's just assume that I can figure out where the pivot is. And let's say that the pivot didn't occur in this location, right? If the pivot didn't occur, I know that this is going to be the largest number. If the pivot didn't occur in this section, I know this is going to be the smallest number. Okay. Of the smallest, sorry, it will be the, if the pivot didn't occur in this section, it will be the smallest number of this section, which it is, 5, 6, 7. Okay. Now, if the pivot did occur in this section, well, we might go 5, 0, 7, right? Like that would, or 5, 0, 1 maybe. And 5 would no longer be the smallest. Like, for example, if this was our section that we were looking at, well, 5, the pivot occurs right here. And so 5 is not the smallest. So let's try to think about this of what we want. So I want to figure out, let's just say if nums of m is greater than target. Okay, so in this case, nums of m, so our midpoint is too big. Our midpoint is too big. So what do we want to do in this situation? Well, the first thing that I want to say is if, and let's just find where the pivot is. So if the pivot, so m is too big, I want to throw away all of this. I would normally want to throw away all of this, except if the pivot occurred here, right? Which nums is too big. Okay, so if, and this is the way that we can figure out if the pivot occurred, if nums of m is greater than nums of right, okay, I'm just going to say pivot occurred, okay. So what do I want to do in this section? So if the pivot did occur, okay. So my midpoint is too big. And now I said, I'm going to change this to be like this, okay? So if my midpoint is less than my right point, that means the pivot did not occur. Okay, so in this case, my m is too big, and all of this, everything to the right of my mid is too big. So I need to get rid of that portion. So right is going to be equal to mid minus 1, okay? Now the other case is going to be that the pivot occurs in this section, and therefore I need to try to go in and determine, do I delete this side or do I delete this side? Okay, So I want to look, so this is going to have some kind of thing where it goes like this in it because it has a pivot, okay? And now I know that the midpoint is too big. And I know that, so if the midpoint is too big, I can find some smaller values in somewhere in my right hand side because there's a pivot, and then I can also find some lower numbers in my left hand side, but my left hand side is continually increasing, so I want to look at that. So I said that my midpoint is too big, right? And I'm looking for something smaller, so I'm going to look to the smallest of my left. So if nums of left is this bigger than nums of mid, would this be the case? So if that is bigger, it means and nums is too big. I keep saying it, but I'm really struggling. Nums is too big, right? Or the midpoint. Mid is too big. Mid is too big, and I'm looking for something smaller. I'll go to the smallest number in there. So if this number, if the smallest number to my right, or to my left, smallest number is bigger than my mid, I can get rid of that left, the entire left point, right? So if this number is bigger than my mid, I can get rid of that. So left is going to be equal to mid plus 1, okay? And now, otherwise, I need to, I can get rid of my right hand side, right? Because mid is going to be, or sorry, my left is going to be smaller than, and this should be target, because I don't care about mid. Okay. Else, I know that that left-hand side is bigger than my target, and so the only other place that it could occur so if the left-hand side is bigger than my target, that's all increasing, I can get rid of it and keep my right-hand side. Otherwise, what I want to do is I want to say that, okay, no, that number is smaller, so I'm going to keep my left. So that means right is going to be equal to mid plus 1. Okay. So now I want to come in here and say if nums of m is less than target. Okay, so if it's less than target, what do I want to do in this situation? So let's say that the pivot occur, so so the middle point is too small now. Okay. if it's too small, I want to see if the middle point occurred, or if the pivot occurred in the left-hand side, or if no pivot occurred in the left-hand side. So if nums of left is smaller than nums of mid, this means no pivot occurred, okay? So that means what I can do is get rid of that. So left, right? Because the midpoint is too small, and everything, there's no pivot in the left-hand side, so I can just get rid of that. So left equals mid plus 1. Plus 1. And this should be minus 1. Okay. So no pivot occurred like that. So now, no pivot occurred in the left-hand side. Now there is a pivot in the right-hand side. So I need to go in and, so else, okay, pivot occurred, okay? So pivot occurred where? Pivot occurred in right side. Oh wait, no, left side, sorry. In left side. No pivot occurred in left side, okay? Okay, so if no pivot occur, or if the pivot did occur in the left side, I want to go in and try to figure out, say, okay, well my midpoint is too small, okay? Who can I throw away? Who can I throw away? So my right side, so the left side has the pivot, okay? Where is the, and my mid is too small. Where's the biggest number going to occur? That's going to be on the right-hand side. So if nums of right is bigger than target, okay, is that correct? So my middle point is too small. I need something bigger. So I'm going to look to see if the right-hand side, which is ever increasing, contains something bigger. If it is, I throw away the left. So left is going to equal mid plus 1. Okay. Else, right is going to equal m minus 1. And then if we ever exit this while loop, we can return negative 1. We'll see if this works. Okay, it passed the test cases, but it passed the test cases last time as well. This is the real thing. Wrong answer. I think I got the same okay. 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 Do I need to take into consideration like equals to? Because target is 3. Do I need to take that into consideration? So if this is the case, right? If length of, okay, so the pivot occurred and I should have said where. The pivot occurred where. So M is less than R. Wait, doesn't that mean that the pivot did not occur? If mid, so pivot, so no pivot occurred in right. So my midpoint is too big, and there's no pivot in the right, so I can get rid of the right. That sounds correct. Okay, my mid is too big, and the pivot occurred in right side, okay? So my midpoint is too big, but the right might have something smaller. The left also might have something smaller. So I'm going to say if the left side, smallest number is so I'm looking for something bigger, and I have my the left side is ever increasing, and I want something bigger, right? No, the mid is too big, so I want something smaller. So that means I look to the smallest number, which is going to be that left. Okay. And if that left is too big, I know everything else is also too big. So I can get rid of it. It's too big. It's bigger than target, so I get rid of it. Makes sense to me. And I've already checked the mid, so I can not consider that anymore. And this is equal to, so it should be okay with that. So now, if it's less than target, so the midpoint is too small, and the left side doesn't have a pivot, then I can get rid of the left. That makes sense. Okay. Otherwise, the pivot occurred in the left side. Yeah, that makes sense too. So if nums of right, so the pivot occurred in the left side, so I'm going to look towards the right side because I know that the right side is always increasing. And my midpoint is too small, okay? It's too small, so I want something bigger. So I look at the biggest number and see if that's bigger than target, right? So if it is bigger than target, then I get rid of the left. Otherwise I get rid of the right. I don't know. Tell me which lines are wrong. Put a comment on the lines only. Okay. I want to find out where it is. Oh, jeez. There's 4 of them. M. So if my midpoint is greater than my right, my midpoint is greater than, oh, yeah. Wait, what? My midpoint is alright, that would be the left, right? I hate this. Okay. So, do I need to go through everything again? I don't want to. I really don't want to. Okay, let me look at this exact thing right here and talk it through with myself to try to figure out, like, okay, well, where did I go wrong and what was I thinking? So the midpoint is smaller. Yeah, the midpoint is smaller than my right. Wait, doesn't that imply that no pivot occurred in the right? Nums of left is, and then this is the exact opposite. Okay. So this case here, I have mid, and my mid is smaller than my right. Okay. So here's my mid right here. And my mid is smaller than my right. Okay, and then this is something like that, right? Should be something kind of like this. Okay, here's my mid. Oops. Here's my mid. But that implies that the right-hand side is. There's no pivot in the right-hand side. It's in the left-hand side. I don't think that's correct. I don't know, man. There's C++. I don't want to. C++. Although it's going to be different because it's like nums of left is greater than or equal to nums of mid. So nums of what's going on right here? The left is smaller than my mid. So that means that there's no pivot in the left. If nums of left is smaller than target, smaller than or equal to target and I really hate this problem. I hate this problem. This is a terrible problem. It's a very valid problem, but I should be able to do it. I don't know why it's giving me so much trouble. I don't know. I just feel like I want to kind of move on and not look at this problem ever again. I might do that. I might just not look at this problem again. I hope it never comes up. Yeah, I think that's what I'm going to do. I'm going to hope that it doesn't come up, and if it does come up, that's going to be a problem. Okay, so there we go. Thank you guys for watching this video. If you want, subscribe. Don't know why you would want to subscribe, but if you do, that's okay. And I will be back with more Leetcode videos in the future. Probably won't be able to solve them, right? I don't have a very good track record of solving problems, but I'll try and try to keep learning. I also do like project videos, so if that's interesting to you, subscribe. Yeah. All right. Goodbye.